Another application of dot product is being able to tell whether you have, whether your vectors are parallel, perpendicular, or neither. And the way that we talk about perpendicular in the context of vectors is to call them orthogonal. So orthogonal just means that we have perpendicular vectors. Oh my. I've been struggling here for a second. Okay. So we have two vectors are orthogonal if their dot product is 0. Two vectors are parallel if you can multiply one vector by a scalar and get the other. So if you can multiply by some kind of constant, you see some kind of multiplication relationship. You can see some kind of multiplication relationship, then that's when you know that the two vectors are parallel. And if neither of those are the case, then your vector is neither. So I usually take a glance at my vectors, see if I can kind of guess and test the multiplication situation. If I can't, I do the dot product. And then if neither of those works, if I don't get a 0 dot product, then I say neither. So let's go through that process. For number 15, I have 3, 2, and 2, negative 3. And if it helps you to get the i's and j's out of there, sometimes that helps me. Just get component form so all you're looking at are numbers. So I can't think of one number that I can multiply 3, 2 by to get 2, negative 3. So I'm going to do the dot product and see if I can get 0. So dot product 3 times 2 plus 2 times negative 3. Multiply your like components. 6 plus negative 6 is absolutely going to give me 0. And if two vectors have a dot product of 0, that means that they are orthogonal. All right. For 16, again, I'm going to write my vectors out, just the numbers. Get rid of the i's and j's. That seems to kind of muddy up the situation sometimes. I'm looking at 2, 4, and 3, 6. If I multiply vector v times 2, I'm going to get vector w. And you can even show that 2 times 2, 3. And since you have that nice scalar situation happening, that means these two vectors are parallel. Again, if neither of those conditions worked, your vectors would be neither.